Hello guys, I'm back on the this. Still no word on the voltmeter. Looks like I'm gonna have to improvise something a little more modern, and I don't want to. And I also found a replacement cap. This is a General Electric 19,000 microfarad. Works just fine, no leakage in spec. My problem is I need to get a way to dump the voltage off of this when I turn the unit off, and I'm going to do that with this big power resistor, 7 watts, 3.3 ohm, and this relay box, which takes 120 volts and has a normally open and closed contact. What's going to happen is when the power is on, this is going to energize and it's going to open the circuit. I'm going to have this on the normally closed. It's going to open the circuit here so this doesn't build up. I can't put this here because this builds up a tremendous amount of heat and pulls a lot of current. So when I kill the power in the front, it's going to close the normally closed contact, which in turn will dump the voltage across this resistor. This is going to be hooked in one leg over and back, and it's going to dump the voltage and take it off this capacitor. Otherwise, this voltage will sit in this capacitor until whatever's hooked to it drains it. If there's no load on it, it's going to sit there, and this capacitor is 50 volts, and I don't want all that voltage hanging around in here. So we're going to clean this up a little, get the sticky off, mount it somewhere in the box. I was going to just use a 12 volt relay and another transformer, but I decided against that because that's just more crap, and besides I don't want it to start singing and things like that or whatever. But and I don't know if I have any lugs for this to get on that are small enough, but I'm gonna have to tie on probably behind the fuse here, which will give me an extension on this lead if I need it. I'll try to just tap on behind the fuse, mount this in here somewhere, get in where you fit in. Get in where you fit in. I'm not real sure where this is going to have to go, but probably right there, like so. Put a common on here and hop one leg here and then start working on this circuit. So I'll be back when I get it wired in, and I'll show you how I've done it. And my other power supply doesn't have a dumping circuit, and I only have one of these relays. I got to order another one or come up with something else for that, but I'll be back in a minute. Okay, I'm back. Got everything pretty much situated. Power resistor in here, soldered on the lugs, screwed it down. Our wire running normally closed here, and the black and the common, the negative, were tapped in behind the fuse on the AC to energize the coil. And here's our power deal here. And just see how that's hooked up. There's our hot going to the coil, our common going to the coil, tied into the nut, the common, the main. We have our positive feeding through this 7 watt 3.3k or 3.3, is it a k? No, 3.3 ohm 7 watt power resistor. Other side of the capacitor to the normally closed terminal of the relay. We have our negative capacitor common of the relay, the negative terminal here. And what happens is when I turn this on, the relay energizes and opens the contact on the capacitor, so it's not passing current through this load. That will allow us to have no current draw on the system. And you can turn it on, and so I got about 12 volts come up And before, if you've noticed before, the system was would hold this voltage because there was no bleeding network. Well, now there's a bleeder, and when I turn the power off, it almost instantly pulls all the power, it dumps all the power into this resistor. It's a little warm for a minute, a second, and then it goes away. Capacitor is completely discharged. There's no current present on the line, as you can see. And you know, what happens when I turn it on, the coil comes in, it opens up that normally closed contact in the relay. When I turn it off, it closes it back, which completes the circuit to dump the power onto that resistor. So that is a modification that will keep power from being here on that. As far as the voltmeter goes, still no dice with it. Also, that new capacitor has capped out at about, I'll say 24 volts under load. You know, you can see as I turn this down to 0 volts, it's still got current on the line. But when I turn it off, it dumps it all onto that resistor. So this is not going to touch that choke, as you know, that much from there. But I'll probably wrap this in tape anyway, just to be safe, or heat shrink it. I could take it off and heat shrink it. I don't know. It worked out pretty good. It bolted right in. It's a 120 volt relay. I've got another one. I might do my other power supply. I don't need to hunt up one of these. And if I can't find another one, another voltmeter, I'm going to probably just put in a more modern digital. It does volts and amps. Or just volts, rather. I've got an amp meter. I could put a panel light here if I wanted, a neon light lamp there. That will show me when it's on. Yeah, call it fixed for now. This, still gotta fix that. It's still got a funky in there, but it works. Those lugs, I do want to change them out in the future. Those ring lugs, I just reused the ones that were there. It's not the best in the West, but it did get it going. And I'm really thinking about re-drilling over here and putting a black here and red there, just so these even up a little more, a little better. I don't know what I'm going to do with that. They work okay like that, but couldn't use the original wing nuts. The washers were all corroded and coming apart on me, and I wasn't going to risk it. Well, yeah, we'll call it done with the Electro D-612T filter DC power supply, and I will see you guys in the next video.